Today we will look at exponents. We will explore this topic in more details later in the course, but let's get started with just a brief introduction to exponents. Exponents are used to show repeated multiplication. Earlier in the course, we discussed how multiplication was repeated addition. So if we have something like 8 times 3, or 8 multiplied by 3, well, we can also write this as 8 times 3 with an x, or we can use parentheses. All of these mean the same thing. And what they mean is 8 plus 8 plus 8. We're taking number 8 and we're adding it 3 times. And this is 24. Now, exponents are repeated multiplication. So a couple terms. We have a base. This number on the bottom, that is the number that we are going to multiply repeatedly. So in our first example here, the base is 8. So we will multiply 8 repeatedly. And then this number on top, that is the exponent. The exponent tells us how many times the base is multiplied. So in this case, our exponent is 3. So what this means is we have a base of 8, so we're going to multiply that 3 times. So 8 times 8 times 8. Well, 8 times 8 is 64. Then times 8. So now we have 64 times 8. So that's 32. So 2 goes here. Carry that 3, 48, 51. So 512. So 8 times 8 times 8, or 8 to the third power, is 512. So here we have 3 examples, and all of them have the same base. They have a base of 5. So we have a base equal to 5. The exponents are different in each case, but the base is 5. So these are powers of 5. So each one of these is a power of 5. 5 is the base. 5 is the factor that's being multiplied a number of times. In the first case, we have 5 to the first power. That's how we would say this, 5 to the first power. So we have the base of 5. And it's multiplied just once. So we have 1 5. And the answer is 5. In the second case, we have 5 to the second power. So we have a base of 5. So we're multiplying 5 2 times. And then 5 times 5 is equal to 25. Now 5 to the second power, commonly the term squared is used for second powers. So this is 5 squared. Now the term squared comes from geometry. Let's imagine we have a square that has 5 rows and 5 columns. So if we counted up these little boxes inside the square, we'd have 5 times 5, which is 5 squared, or 25 boxes. And then finally we have 5 to the third power. So we have a base of 5, exponent of 3, so we have 5 times 5 times 5. Well, 5 times 5 is 25 times 5. So let's go ahead and do 25 times 5. 5 times 5 is 25. Carry the 2. That's 10 plus 2 is 12. So this is 125. And when something is raised to the third power, we often call that cubed. Now, instead of a 5 by 5 square, we have a 5 by 5 by 5 cube. This is composed of small cubes. And to count the number of cubes we have, we would multiply 5 times 5 times 5, which is 5 to the third. So we have 125 little cubes that make up this 5 by 5 by 5 cube. Now let's practice simplifying some expressions. So 7 to the 4th power. So we have a base of 7, and we're multiplying that 4 times. 7 times 7 is 49, times 7 times 7. So I'm just going to go ahead and just multiply in pairs each time. So now we have 49 times 7. Well, that's 63. Carry the 6. 28, 34. So 49 times 7 is 343 times 7. So we'll multiply by 7 again. It's 21. 28 plus 2 is 30. And then that's 21 plus 3 is 24. So we have 2401. So 7 to the 4th power is 2401. So in this second case, our base is a fraction. So we're going to multiply this fraction to itself 3 times. So we have 2/5 times 2/5 times 2/5. And a few lessons ago, we practiced multiplying with fractions. So we're going to do 2/5 times 2/5. We multiply fractions. We go numerator times numerator, which is 4. Denominator times denominator, that's 25. That's that first pair. And then we have 2/5 again. And then 4 times 2 is 8. 25 times 5, we did on the previous slide, and that's 125. So now we have the decimal 0.3 raised to the 4th power. So we will multiply 0.3 4 times. Again, when we raise something to the 4th power, that means we're multiplying whatever that base is 4 times. And again, we'll continue to multiply in pairs. So let's go 0.3 times 0.3. Well, 3 times 3 is 9. We have 2 decimal places, so that's 0.09. So 0.09 times, and then 0.3 and 0.3. So we'll do another round of multiplication. 9 times 3 is 27. We have 3 decimal places now. So that gives us 0.027. Times 0.3. So one more multiplication. So 7 times 3 is 21. Carry that 2. That's 6. And then 8. And then we have 4 decimal places. So we end up with 0.0081. Notice that we started with 1 decimal place. We were taking a base that had 1 decimal place, 0.3, and we took it to the 4th power. We ended up with 4 decimal places. Now let's look at examples where our base is negative. So for this first problem, we have -9 raised to the 4th power. And these parentheses matter because they mean that it is -9 we are multiplying 4 times. This is different. This is not the same as negative 9 to the fourth power, written without the parentheses. These are not equivalent expressions, but we'll talk more about this later when we discuss PEMDAS and order of operations. So we'll continue to evaluate these, working from left to right, doing pairs of multiplication. So negative 9 times negative 9 is 81. And then we have negative 9 times negative 9. So now we have 81 times 9. Gives us 9 and 72. So it gives us 729. Now 81 was positive and then negative 9, so this is negative 729. And times negative 9. So we have one more round of multiplication. 9 times 9 is 81. 8 goes there. That's 18, so 26. Carry the 2, 63, 65. So we have 65, 61. We have a negative times a negative, so this is positive. In the second problem, we have the fraction negative 1/4 raised to the third power. I'm going to put my negative sign with my numerator. It helps me keep track of that negative and when I've multiplied by it. But this is not required. We reviewed multiplying fractions a few lessons ago. So again, when we multiply by fractions, we do numerator times numerator, and then denominator times denominator. So negative 1 times negative 1, well, that's positive 1. And 4 times 4 is 16. So we have 1 over 16 times negative 1/4. And again, 1 times negative 1, well, that's negative 1. And then 16 times 4. That's 24, carry the 2, and then 6. So over 64. So negative 1 over 64 is our answer. And then finally, we have negative 2.2 squared. So this is negative 2.2 times negative 2.2. So let's go ahead and multiply these out. And using those rules of multiplying, we'll ignore the signs at first, and we'll just multiply these numbers. So 2 times 2 is 4. 2 times 2 is 4. Now we're with our tens, so we're going to put a 0 in the ones place here. 2 times 2, believe it or not, is still 4. So we have 4, 8, 4. 2 decimal places, so we have 4.84. And then we have a negative times a negative, so the answer is positive. Maybe you noticed a pattern forming here. That when we had an even exponent, so 4 is an even number, and we ended up with a positive number. And over here we have 2. Well, that's also an even number. It's divisible by 2. And once again, we end up with a positive number. But when we had an odd exponent, our answer was negative. And this is because when we multiply a negative number an even number of times, we're always going to have a pair of negative numbers. And a negative times a negative is a positive. So over here we have pairs of negative 9. So we have one pair here. That's a positive number. And then another pair here. And so we end up with a negative times a negative with a positive. But when we have an odd exponent, like for 3, again we have a pair. And so this will be positive. But then we always have one negative left over. And so the answer is negative. A great way to learn is to practice on your own. We will discuss in a bit But go ahead and pause your screen and do these 6 problems. So these 6 problems represent a great review of the last handful of lessons as we practice multiplying whole numbers, decimals, fractions, negative and positive numbers. We're also practicing writing this power as multiplication. So 12 to the 3rd power, or 12 cubed, is 12 times 12 times 12. If we multiply that out, we get 1,728. Get a review of multiplying with decimals and multiplying with fractions. For these last two, they're quite similar. We have negative 2 to the 5th power, and then negative 0.2 to the 5th power. And we end up with similar numbers, in this case negative 32 versus negative 0.00032. Continue practicing using exponents, and I'll see you in the next video.